Hey everybody, Bansal here and welcome back to the shop. Today we're diving deep into the world of carbide inserts, those little bits of magic that make machining possible. Now, whether you're a seasoned machinist or just starting out, we all know the frustration of a chipped insert or a less than perfect finish. These things happen, but the good news is that many common issues stem from a handful of easily avoidable mistakes. That's what we're tackling today, folks. We'll break down those common carbide insert blunders and, more importantly, how to steer clear of them. We're talking better performance, longer insert life, and ultimately a smoother, more enjoyable machining experience. So, let's get to it. All right, let's talk insert selection, because this is where it all begins. Think of it like this. You wouldn't use a butter knife to cut a steak, right? Same goes for carbide inserts. Each insert geometry, coating, and the material is designed for a specific purpose. First off, you've got to know what you're cutting. Are you working with steel, aluminum, something exotic like titanium? Different materials require different insert grades. A tough, heat-resistant grade is essential for steel, while aluminum needs something sharper to avoid gumming up. Then you've got to consider the cut itself. A heavy roughing operation demands a tougher, more wear-resistant insert than a fine finishing pass. And don't forget about the shape of the cut. Square, round, trigon, diamond. Each insert shape is designed for specific applications, and using the wrong one can lead to chatter, poor surface finish, or even a broken insert. Remember, choosing the right insert isn't just about getting the job done. It's about doing it right, safely and efficiently. Take the time to consult the manufacturer's recommendations, and don't be afraid to experiment a bit to find what works best for you. Let's talk speed cutting speed, that is. Getting this right is crucial, folks. Too slow and you're just rubbing, not cutting. Too fast and you risk overheating the insert, leading to premature wear or even catastrophic failure. Finding the optimal cutting speed depends on several factors. The material you're cutting, the type of insert you're using, the depth of cut, and the machine's capabilities. Luckily, there are some good rules of thumb and even better resources available to help you dial it in. A good starting point is to consult the insert manufacturer's recommendations. They often provide charts and tables with suggested cutting speeds for different materials and operations. But remember, those are just guidelines. You might need to adjust the speed based on your specific setup and the desired finish. Experimentation is key here, but always err on the side of caution. Start slow, gradually increasing the speed until you find the sweet spot where the cut is smooth. The chips are evacuating properly and the insert isn't showing signs of excessive wear. All right, let's talk chips. Specifically chip control, because let's face it, nobody wants a face full of hot metal shavings. But chip control is about more than just safety. It's also critical for surface finish, tool life, and overall machining efficiency. See, those little metal ribbons flying off the workpiece can tell you a lot about what's happening at the cutting edge. Long, stringy chips can indicate poor chip breaking, which can lead to chip build-up on the workpiece, or even worse, get tangled around the tool. This can cause chatter, poor surface finish, and even damage to the insert or workpiece. The key to good chip control lies in selecting the right insert geometry and cutting parameters. Inserts with built-in chip breakers are designed to create short, easily manageable chips that are ejected away from the cutting zone. Factors like feed rate and depth of cut also play a role, so it's all about finding the right balance. Remember, effective chip control means a safer, more efficient and higher quality machining process. So pay attention to those chips and don't be afraid to adjust your parameters until you're getting the desired results. We're talking about holding those carbide inserts securely in place. This might seem obvious, but you'd be surprised how often a poorly seated insert can ruin your day and your workpiece. Think of it like building a house. You need a solid foundation. In machining, that foundation is the insert pocket, and it needs to be clean and free of debris. Any chips or burrs in there can prevent the insert from seating properly, leading to vibration, chatter, and ultimately a poor cut. Next up, make sure you're using the correct insert screws and tightening them to the manufacturer's specifications. Over-tightening can damage the insert or the tool holder, while under-tightening can allow the insert to move during cutting, leading to all sorts of problems. And here's a pro tip: use a torque wrench. This ensures consistent clamping force and helps prevent those oops moments when you realize you've over-tightened an insert screw. Remember, a securely installed insert is crucial for accuracy, safety, and optimal cutting performance. Here's something close to my heart's sustainability. And guess what? Carbide inserts play a role in that. See, carbide itself is a valuable material, and recycling those used inserts not only reduces waste, but also conserves resources. Now you might be thinking, what can I do? I'm just one person, but every little bit helps. Many companies specialize in recycling carbide, and they make it easier than you might think. Start by collecting your used inserts separately. Don't just toss them in with the regular scrap metal. Once you've got a decent amount, contact a reputable carbide recycler. They'll often provide you with a container and even a range for pickup. Recycling carbide not only reduces the need to mine virgin materials, but also saves energy and reduces greenhouse gas emissions. So, by making a conscious effort to recycle those little bits of carbide, you're contributing to a more sustainable future. And that, my friends, is something to feel good about. So there you have it. We've covered a lot of ground today, from choosing the right insert for the job to the importance of proper installation and even the positive impact of carbide recycling. Remember, machining is a craft, and like any craft, it's about constantly learning, refining your skills, and always striving for improvement. By avoiding these common mistakes and implementing the tips we've discussed, you'll be well on your way to achieving better results, longer tool life, and a safer, more enjoyable machining experience. Thanks for joining me in the shop today, and as always, don't forget to subscribe and hit that notification bell so you don't miss out on future videos. Until next time, keep those chips flying.